Hi friends, here is a really nice problem. X plus y equals 1, x power 5 plus y power 5 equals 31. How do we solve this? Clearly, we have a power of 5. So, let us try to raise this equation also to the power of 5 and subtract this one and see whatever extra terms that we have. Okay, because raising this one to the power of 5 is actually very easy. We know our binomial theorem. Right, let us use that. What is a plus b whole power n? It is nc0, a power n, b power 0, nc1, a power n minus 1 and b power n, b power 1, nc2, a power n minus 2, b power 2. Basically, a power will go from n minus 1, n minus 2 till 0. And b powers will go from 0, 1, 2 up to n. And this one the coefficient will go from NC0 to NCN. This is our familiar expansion, binomial expansion, right? Let us use this for x plus y whole power 5, which becomes pi c0 x power 5 plus pi c1 x power 4 y, pi c2 x cube y square, pi c3 x square y cube, pi c4 x y power 4, pi c5 y power 5, right? Now we know NC0 is 1, NC1 is n. So phi C1 is 5, phi C2 is 10, phi C3 is also phi C2 which is 10, and phi C4 is also phi C1 which is 5, and phi C0, phi C5, these are all ones. So this expansion becomes x power 5 plus pi x power 4y plus 10 x cube y square plus 10 x square y cube plus pi x y power 4 plus y power 5. Now, this one, whatever we have got, x plus y whole power 5 minus whatever the original one. Let's do this. Okay, this raised to the power of 5 minus this. That's what we will do. Now, this minus x power 5 plus y power 5. So, basically these two will go away. X power 5 and x power 5 and y power 5, these two will go away. We'll be left with 5 x power 4y 10 x cube y square, 10 x square y cube, 5 x y power 4. And x, this is 1 minus 31. Right, 1 power 5 minus 31. Right, so which is minus 30. We can cross out this 5. We can remove this 5 because 5 is a factor everywhere. So we'll be left with x power 4y plus 2x cube y square plus 2x square y cube plus xy power 4 equals minus 30 by 5 minus 6. Right. Again, we can take xy common, xy, x cube here plus 2x square y because it is 2x cube y square. So we'll be left with 2x square y. Similarly, 2xy square from here plus y cube. Right. If we are taking xy out. Right. Now here again we are getting x cube and y cube. We have already x plus 1. Right. Let us try to cube x plus 1 again and let's see. Okay. So we have xy. Let's take this time. Xy times x cube plus 2x square y plus 2xy square. Let us continue from here. Right. We can take xy common from this middle two terms, right? These middle two terms, xy we can take common. Right, if you take xy or 2xy, we'll be left with 2xy times x plus y. Right, 2xy times these two terms. If you take 2xy common, 2xy times x plus y. But x plus y is 1. So these two terms will reduce to 2xy only. Right, that's what we are doing here. These terms will reduce to 2xy and xy into that 2xy will become 2x square y square. Basically, what we are doing here is xy times x cube plus 2xy times x plus y plus y cube equals minus 6. This x plus y is anyway equals 1. That was the original problem. X plus y is anyway equal to 1. Right. So this one will go away. So this one will go away. We'll be left with 2xy. Then if we expand this, xy times x cube plus y cube plus 2xy into xy, which is 2x square y square, plus this minus x will come to the side plus 6. Right? So this simplifies to this. Now x plus y cube. What is x plus y whole cube? X cube plus 3x square plus x square y plus 3xy square plus y cube. We already know. This is general expansion. Right here also, these two terms we can write them as 3xy times x plus y. X plus y is anyway 1. So this boils down to x cube plus y cube plus 3xy equals to 1. So x cube plus y cube equals 1 minus 3xy. Right. This is another result. Is not this important results. So we started with x plus y expansion, and we subtracted. We started with this power 5 and subtracted this and simplified this. We simplified. We kept on simplifying, and finally we arrived at this result. Right. This is what x plus y whole power 5 minus x power 5 plus y power 5, that simplified to this. Right. Now here this x cube plus y cube we are replacing with 1 minus 3xy. Right. So that the entire equation is in terms of xy. Right. That's what we wanted. Right. Instead of 5 powers, the original equation was in 5 powers, right? Now we want to simplify those 5 powers. So we reduce that to 3 powers first. And these 3 powers also we are getting in terms of xy. Right, now let's put this 1 minus 3xy in this equation. So xy times x cube plus y cube is 1 minus 3xy plus 2x square y square plus 6 equals 0. So let us just expand xy minus 3x square y square plus 2x square y square plus 6 equals 0. So which becomes minus x square y square plus xy plus 6 equals 0. If you multiply with both sides and call xy as some v just for simplicity, v square minus v minus 6. So this becomes, if you multiply with minus 1, then xy equals v. This becomes v square minus v minus 6. This is very easy to solve. V square minus 3v plus 2v minus 6 equals 0. V is 3 or minus 2. What is v? V is our xy. Xy is either 3 or minus 2. So now the equations are massively simplified. We have xy, we know x plus y also. Right, we have got xy here. xy from v. So xy equals 3 or minus 2. Right. And x plus y is 1, which is what we were given originally in the problem. X plus y equals 1. xy is either 3 or minus 2. Let x plus y is 1. So we have two combinations, 1 and 3, 1 and minus 2. We have to solve these two combinations. Let's try and solve these two combinations. One is xy is 3, x plus y is 1. xy is minus 2 and x plus y is 1. Right. What is, we know x plus y, we know xy. We can calculate x minus y also. How? X minus y whole square equals x plus y whole square minus 4xy, right? So 1 minus 4 3 is 12 minus 11. So x minus y becomes plus or minus root 11i. Right. Now x plus y is 1. X minus y is root 11i or minus root 11i. We have for x plus y equals 1, we have two x minus y's. Right. Plus root 11i and minus root 11i. So this one has given rise to has has given these two forms, right? X plus y equals 1 when x minus y is less root 11i and minus root 11i. Similarly, xy equals minus 2, right? Then x plus y equals 1. X minus y whole square is 1 minus 4 times x square. 1 minus is x plus y whole square, right? X plus y whole square minus 4xy. X minus y whole square is x plus y whole square minus 4xy. Minus 4 times xy is minus 2. 4 times minus 2. So 1 plus 8 which is 9. So x minus y is plus or minus 3. Right. So x plus y equals 1 again. And x minus y is either 3 or minus 3. So we have four sets of equations that will solve. That will satisfy this original set of two equations, original set of these two equations. Right. If you simply solve 2x equals 1 plus root 11i, so x becomes 1 plus root 11i by 2. Y is 1 minus x, which is 1 minus root 11i by 2. X here 2x equals 1 minus root 11i. X becomes 1 minus root 11i by 2. And y is again x minus 1. Y is x minus 1 in this case also, in this case also. Sorry, y is 1 minus x, right? X plus y is 1, y is 1 minus x. So 1 minus x is 1 minus of 1 minus root 11 I by 2, which is 1 plus root 11 I by 2. Here 2x equals 3 plus 1, 4 by x equals 4 by 2, which is 2. And y is x plus y is 1. So y is minus 1. X here 2x equals minus 2, x equals minus 1, y equals 2. So we have these four solutions. Right. What we have done? We have we have raised this to the power of 5 and subtracted this. Right. And when we subtracted, we got this equation. We got in terms of cubes, but cubes are also not sufficient. Cubes, we figured out cubes can also be expressed in terms of xy, in terms of xy, because we have x plus y equals 1, x plus y equals 1. So that means cube can also be expressed in terms of xy. So this entire second equation we are able to express in terms of xy. Right. And we solved and figured out xy can be 3 or minus 2. We have x plus y equals 1. Right. So what is x plus y equals 1 and xy can be 3 or minus 2. That is giving 2. That is given to x plus y equals 1 and xy equals 3 or minus 2. So this set is giving two solutions and this set is giving another two solutions. So total four solutions. That is what the problem is about. Two imaginary solutions and two real solutions. Right? Yes. Hope you like this. Thank you.